On behalf of Inago and Academic Labs, I welcome you all to today's webinar on finding a perfect research collaborator, how to build a robust research network. So today we have with us Dr. Despina Sanadu and Arnie Smolders. We welcome you both. Despina holds a PhD in molecular cytogenetics from University of Cambridge and currently works as an associate professor at medical school at Department of Internal Medicine at University of Athens. She's a renowned medical researcher and a well-published author with more than 80 publications and more than 3,700 citations to her credit. She has also been associated with Harvard Medical School as a postdoctoral fellow and an instructor. Today, she will share with us best practices for finding a compatible research collaborator and also give her personal insights through her extensive experience in academia. We welcome you, Despina. Arnie is the life science researcher turned entrepreneur with a passion towards bringing transparency in the scientific ecosystem. He is currently the founder and CEO at Academic Labs. Following Despina's session, Arnie will introduce Academic Labs, which is an excellent platform to facilitate matchmaking, resource sharing, and collaboration in academia and R&D-driven companies. Now, moving on to today's topic, I will now hand over the mic to Despina.
So, hello, can you hear me, everyone? I hope you can. It's an honor and a pleasure to be with you today through Inago. My presentation will focus on research collaboration, trends in research collaboration, finding good collaborators, and setting up collaboration, maintaining it, and how to move forward from there. So, starting from the basics, when we talk about collaboration and collaborative research, we're basically talking about research that is conducted by more than one researchers or research teams, either within or across institutions, to achieve the common goal of producing new scientific knowledge. Why collaborate? There's many reasons why one would want to pursue collaborations in the field of sciences. Collaboration is instrumental between young and senior scientists because it shares experience, it conveys momentum, it builds motivation. And this is just one type of the different forms of collaboration one can have. We have collaboration between peers in order to solve complex scientific questions. So through collaboration, we aim to bring together experts from different disciplines who will share their expertise, their knowledge, their skills, and also their perspective in order to achieve a synergistic outcome. Also, you will find that in many different countries, funding agencies, as well as international funding agencies, are moving more and more towards funding interdisciplinary research. In Europe, this is very much supported by the European Union, very much encouraged, and the majority of grants push forward for collaboration, but you will find the same trend across different countries. So experts from different disciplines, from different backgrounds who will contribute, work as a team to achieve a common goal, to answer a shared scientific question. And a great example of that is the translational form of research, where you try to take findings from the experimental laboratory level to the clinical practice. And by definition, there you need a whole broad range of different experts from the different steps, from the different fields. So in typical research collaborations, you will find different levels where a collaboration can take place. So you can have collaborations within a team, within the scientists of a team, whether they're at the same level of scientific maturity, if you want, or at different levels, nevertheless working in the same laboratory, in the same team. This is something that takes place in most laboratories, in most centers. Beyond that, though, you can have collaboration between different research labs. You can have collaboration between different academic institutions, of course, between different disciplines, whether this is in the same or different research center or academic institution. And then you can build on to have collaborations across different countries or with the industry. Each level of collaboration brings additional benefits to all members involved, and in a smooth and effective collaboration, the outcome and the benefits for all are really additive. So every one of these levels needs to be considered as a scientist gradually matures in their field, and all of them will eventually become important in achieving the bigger goal of answering broad scientific questions and achieving the translation of their findings either to the clinic or to the industrial setting. Now, there are different types of collaboration arrangements, and two main, I could say, types of collaboration is this of vertical research and this of horizontal research. Now, when we talk about vertical research collaboration, the focus is more narrow. We're talking about largely intradisciplinary collaboration, which means collaboration of investigators who work within the same discipline, but it permits interorganizational or interinstitutional collaborations. A prime example of that would be the collaboration developed between a supervisor and their student or students. This is a vertical research type collaboration. And this is usually a type of collaboration with a high chance of success because you have the close interaction, close both in terms of how frequent it is, but usually because it's physically close in the same laboratory or in the same research center. So this close interaction allows for more focused, more regular communication, and faster answers to the scientific questions. Now, the horizontal research collaboration is of a broader scope, is usually interdisciplinary, so scientists from different disciplines who come together to collaborate to answer a common scientific question. Again, here we can have interorganizational or interinstitutional collaborations. And a prime example of that would be a collaboration between biologists and chemists, for example, to answer scientific questions that affect both. Another example would be collaboration between biologists and clinicians, etc. But the horizontal research collaboration is usually broader, involves many different people from different settings, from different disciplines, so it requires usually more effort to keep the momentum, to keep these collaborators together, working efficiently, effectively, and in a timely fashion. Now, what are the current trends in research collaboration? How are things developing at a worldwide level? And you can find some very interesting literature demonstrating with actual hardcore data how collaborations are building and are playing a greater and greater role in the field of science. So as you can see in this publication in Scientometrics in 2018, the number of publications involving collaborations across different countries, two or more countries, has been increasing steadily from 2000 onwards. And as you can see in this slide, the number of publications involving only domestic USA partners is starting to decrease and is starting to be more and more replaced by papers that involve more and more collaborations. The trend is now starting to shift, as you can see, but this is anticipated to increase much more in the years to come. Now, if you look at other countries, and a great example of that is the Netherlands, you'll see that the vast majority of papers published involve collaboration with other countries. And actually, the Netherlands at the moment ranks first in terms of number of publications involving many international collaborations. So you can see here examples of papers that are published in collaborations with scientists from a range of different countries. Now, if we look into this matter further, you will find some excellent graphical representations of the global developments at the moment. So in the slide here, you can see how research centers from each one of the different countries stated here are collaborating with other countries across the globe. The size of the dots that you're seeing correspond to the number of collaborations. So the greater the circle, the more the collaborations. And as expected, the United States of America has the largest number of collaborations with other countries, and China is now coming up as the second most rapidly evolving country in terms of the international collaborations and output. Of course, well-established research centers with a long history in Germany, United Kingdom, and France, they have been steadily demonstrating extensive international collaboration. All this, of course, is dynamic and it's changing from year to year, facilitated both by the rapid development in science, the evolving needs in science, but also greatly facilitated by the technological advancements that make communication much easier. And of course, by the tools that we will discuss shortly that facilitate the identification of collaborators and the establishment and maintenance of these collaborations. Now in this field, what you can see in this slide is the top 10 collaborators in terms of countries across the globe. So you can see from a close-up the United States, China, Germany, UK, France, and following them Switzerland, Italy, Australia, and Japan. Top 10 collaborators in terms of how many different collaborations have been established with how many different countries across the globe. And the gray lines that you're seeing and the colored lines all have to do with number of collaborations. Now, if we were to compare the US versus China, the statistics that involve collaborations established, you can see them in the graphics here, and you can see how they are both evolving over the years, and they have to do not only with life sciences, but physical sciences, environmental, chemistry, etc. Each country puts emphasis in different fields at the moment in terms of how many scientists and how many collaborations for each field are ongoing. But as you can see, there's their top institutions compared with a large number of collaborations internationally. Now, if you look at the different disciplines separately, in this graph you will see how the statistics from 2006 and 2016 compare these two different shades of green, and you can see how many international collaborations by subject area have been changing in the different fields over this decade. So basically, in every single one of these fields, you'll see that in 2016, the number of international collaborations has increased. For some disciplines, this is slightly greater than others, but as a percentage, it's pretty much a consistent and impressive change in the trend. So international collaboration is by all means increasing, becoming more intense, more extensive, and this is affecting scientists from all different science and engineering fields. It's a great example that in fields such as physics, you can have manuscripts, papers with more than 1,000 authors, and an example here, the record paper in physics with more than 5,000 authors, where it was published in 2015. So you can see how things are really changing. Collaboration is really important. And the fact that these graphs and these papers that I just showed you have been published just proves the fact that collaboration is not only a personal need for a young scientist, but it's an important need for any stage, a scientist of any stage, of any discipline, and it's to the benefit not only of their own personal career, but also the benefit of science itself, because it facilitates the more effective, the more rapid development. But how do you find good collaborators? And this is a very, very important question and very important approach that one needs to carefully consider. So how does one find a good collaborator, and what do we mean by a good collaborator? Let's investigate the answers to those questions in the coming slides. So when do researchers need collaboration? Well, they need collaboration because it can bring together experts with different skills, with different background and knowledge. It can bring together scientists with different material or data, and by different, we mean different that will be complementary. For example, if I'm conducting a study on a specific, for example, skeletal myopathy, I will need to collaborate with clinicians who see patients with these rare diseases, clinicians who work not only in my hospital or my city or my country or my continent, but experts, clinicians who see such patients from all across the world. So I will have to look out, search, identify them, and try to connect with them. This would be an example of people collaborating, scientists collaborating because they can share material. Another example would be collaborating in order to share data that have been generated by one team and can be helpful to another team to use in order to build on that, bring together their own data, and therefore help answer a bigger question. Another very good reason for collaboration is in order to bring scientists together who have access to different complementary infrastructure. And some of the equipment one is required to use can be very expensive, very specialized, may need very strong expertise in order to use them or to interpret their outcome, their data. So all these are reasons why collaboration can help a scientist move forward. This is so much more the case when we're talking about younger scientists who, in addition to all that, very much need the mentoring, the advice, the experience of the more mature scientists. But how does one start to search for collaborators? And this is quite a challenge when one is trying it out for the first time or the first few times, or when they're trying to connect with scientists in completely different fields. So the first way to approach it is through face-to-face interactions, and this is the more traditional way. So by reaching out to scientists from the same institution or the same professional association, scientists they will meet at conferences or try to find at conferences, workshops, or seminars. Another way is going through colleagues and existing collaborators. So for example, if you're looking for someone who's specialized in a very specific discipline, you can ask your colleagues or your other existing collaborators if they know someone they would recommend in this field. And the third approach would be the online resources. So this would be either through publications, which is also a rather traditional approach. So you go through manuscripts, the papers, publications, trying to identify who is really an expert, a top expert in the discipline that you want to collaborate with. You can read about their work, read what they have done, and then reach out to them, email them, try to build a connection. This can be more challenging than the face-to-face interaction. Beyond that, you have scholarly networks, you have social media, And increasingly, you have specific networking online resources. And this is a tool that's becoming more and more popular and can be increasingly helpful. And you will hear a lot more about that in the rest of this presentation. So, tips about building new connections. It's very important to find collaborators who are compatible to you as well as to each other. It's instrumental that not only your scientific knowledge is complementary, but that the personal chemistry, the way you can interact with the other person, is good, is effective, works well, and sometimes only time can answer this question, but usually with experience comes the ability to identify those individuals that you can work best with. And this is instrumental for establishing a fruitful collaboration, a collaboration that will last over the years. It's also important to make sure, especially in a multi-collaborator team, that each collaborator has a unique skill set. So each one should be bringing in something additional to the network that you're going to be building. So what are the qualities of a great collaborator? It could be a very long list to discuss, but if one was to summarize some of the key qualities to a great collaborator, this would be to have complementary skill set, someone who is curious, who likes to ask questions and find answer to questions, someone who's a problem solver because problems will inevitably arise in research, someone who's appreciative, someone who connects the dots or even creates the dots, someone who gives and expects trust, and someone who seeks to find answers to the bigger scientific questions and does not stay permanently focused on the very narrow scientific questions. It's good if it's someone who is able to listen in order to understand and who is willing to share his experience and give his advice, someone with networking and diplomatic skills. I could go on and on really about the different attributes a great collaborator could have, but the ones summarized in this slide I consider to be instrumental in order to have a promising collaboration. So try to seek out for them. Now, before you begin setting up a collaboration, you need to determine exactly what it is that you need from a collaborator, a potential collaborator. So try to have a clear picture what it is that you will be asking for. 2. Weigh the potential risks. In a collaboration, you will have to disclose information, you will have to disclose unpublished data. You have to weigh the risk because you're seeking to collaborate so often with people that you've never met, you don't know. So it's good to weigh the benefits and the risks and move forward accordingly. Select your collaborators strategically. So choose them based on the attributes we discussed, as well, of course, and above all, their scientific merit. You may want to consider their location, in which institutions they're based, in which countries they're based, what infrastructure they have access to, etc. There's many different criteria on how to strategically select your collaborators, but these will largely depend on the reason that you need a collaborator. What do you need them for? So that's why determining your need, which was stated in point 1 on this slide, is absolutely critical and affects all the other steps. Now 4, you need to weigh what you can offer. In a collaboration, it's all about giving as well as receiving. So weigh what you will be able to give, because this will be important when it comes to negotiating, establishing your agreements, and moving forward. Then you will need to contact your potential collaborators, and you need to think about how and when to do that. And 6, once you've established the network of collaborators who are willing to work with you towards a common goal, it's best to reach a clear, mutually beneficial agreement, and to do that right from the start to avoid any misunderstandings in the process. So let's look at these points in a little more detail, each one of these 6 points. Setting up a collaboration. First things first. So, what are the common goals? What is to be exchanged and expected through the collaboration? These are all very important to determine. How will work and any products be shared? How will any funds available be shared and spent? How will responsibility and credit be shared? What are the timelines for each goal? And who will be responsible for sending reminders, for ensuring that these timelines are respected? One of the very important things is negotiating a collaboration agreement. So take note of the institutional, regulatory, funder requirements, as well as country-specific mandates. This is very important and needs to be considered right from the start. Identify and address all critical elements prior to starting the project. Define the contributions of each member of the team in terms of supplies, equipment, and facilities. And it's usually important and helpful to sign MTAs right from the beginning, material transfer agreements. So what each one is willing to provide to the others and under which conditions. It's also useful to discuss right from the beginning any intellectual property issues that are relevant to the project that will be pursued while making the collaboration agreement. Roles and responsibilities is another important point to clarify earlier on. So who will be the person leading the project, the effort, the collaboration, the network, however you want to call it, and what are the powers vested on this individual? What will their responsibilities be? It's very important what their rights will be and how these will affect the dynamics of the entire team. In terms of team members, the rest of the team members, it's important that they have clearly defined roles and clearly defined expectations. And of course, this will depend on the scope of the project and the expertise of the different members. I'm sorry, I'm having some technical problems moving my slides forward. So in terms of data management, sharing, and ownership, key points to consider: how will data be collected, managed, and shared to ensure research integrity? Who will be responsible for collecting them? Will there be a shared database? Who will have access to this database? When will the data be shared? Who will hold the ownership? Under which conditions will the data be shared? It's also important to have data security plans and electronic data backup. Who will be responsible for that? Also, the software to record or manage the data. All this is useful to clarify from the beginning so that it's mutually agreed what's going to happen and it's avoided that any data are lost or kept by only one of the partners or disclosed at an inappropriate time too soon or too late. It's also important to clarify these issues to avoid any misunderstandings, because it's only human to sometimes misunderstand the intentions of the other person, and this could lead to unnecessary complications. It's very helpful also to discuss authorship plans from earlier on, especially when you will be collaborating with people that you don't know. It's good to ensure that everyone's on the same page, and bear in mind that the rules for authorship and publications sometimes vary between different countries or between different institutions or even between different fields, disciplines. So it's important to clarify from the beginning what is expected from the different collaborators earlier on to avoid unpleasant surprises at a later stage or again misunderstandings. So who has the right to publish the data? Who will write what? Who can present the results in meetings, potentially before a publication or even after a publication? What will the author sequence on a publication be? And ensuring acknowledgement of all contributors. Of course, as you can understand, some of these matters are a little difficult to establish right from the beginning because, for example, author sequence can greatly depend on the amount of work contributed by each collaborator towards a specific publication. And although they may all have contributed equally towards the project, for a specific publication that may be presenting only part of the data, the contribution percentage of each partner may vary. So to some extent, you can discuss these from the beginning. To some extent, you will need to allow for flexibility to adjust according to the actual progress and contribution of each collaborator along the way over time. Sometimes, although not often, conflict of interest may arise. Challenges may be encountered. Uh, for example, there are different styles and different personalities of individuals. They will be invited to participate in a collaboration, but nevertheless, these differences may lead to conflict of interest. Sometimes the different approaches by different specialties in a multidisciplinary research project can be the cause. Other times it can be the challenges encountered during a project or their causes that brings frustration and conflict. Inadequate communication or pure misunderstanding. These are some of the most common reasons. Of course, several more can exist. But in any case, in the scenario where any of these or other causes for conflict of interest take place, it's important to talk about it in a polite, courteous, respectful manner, try to find a resolution to the conflict, and try to engage all partners so as to clarify matters timely, efficiently, effectively, as early on as possible, so as to avoid having a problem that endures over time and causes greater damage. Maintaining a collaboration is a skill, an important skill to develop. So for maintaining a healthy and fruitful collaboration, it's very important to invest time. Ensure highest quality of work. Be punctual, be reliable, build strong relations with all other collaborators. Always be respectful and supportive to the team leader. They have an important and difficult job to implement. Try to tie up the loose ends. Attend to any technical challenges or any other challenges or conflicts, like we said. Try to identify them if they are in your team or in other teams, in your lab, in your hands or in other hands, and try to uh, find solutions, either by asking for help from others or by offering help to others. Fast resolution is very important to ensure the momentum of a project and to avoid a problem growing to something bigger than it really is or it should be. Keep it going. Maintain regular and open communication. Set regular online or in-person meetings. This is really important. Regular communication maintains the momentum. It's motivational for all. And add new partners if needed, if new skills are needed, if new access to new infrastructure is needed. but keep this option open. It's important to track progress, to communicate success within and outside the network, to find reasons to encourage and motivate each other, to help each other troubleshoot, and overall create an environment of support. When one feels supported, encouraged, and motivated, they can achieve so much more. So a collaborating environment should be a warm, homey environment where everyone wants to give their best, wants to share, work as a team, help each other, move forward, give their best. So there are tools today that can help considerably in identifying, establishing, maintaining a collaboration, and seeing it through. Some of these examples are presented in this slide, and I'll just mention Mendeley, Academia.edu, LabRoots, Bentlin, ResearchGate, and InnoSpin. There are others you will find, but these are some of the top ones available today, and I would encourage you to look into them, become familiar with what they have to offer, and identify the ones that can really help you address and meet your specific needs. It's great that these tools are now becoming available because they can really help things move faster, more effectively. So what about opportunities and obstacles in collaborations? Some of the benefits of research collaboration are obvious to all. Some of them it takes experience to appreciate. But if I was to summarize the top 6 in a slide, this would be the ability to capitalize on a broader range of resources, to have access to complementary skills and knowledge, to improve efficiency and research productivity, increase global exposure, boost your citations, and establish diplomatic relations that will follow you throughout your career. There's a lot to be said about each one of those different points. But they're not the only ones. The benefits from a research collaboration are really great, a lot, and extend to many different directions in one's career. An important point, as you saw in the example of benefit number 5 in the previous slide, is the impact it can have on your citations. And there are studies to show how who you collaborate with can affect the citations that your work, your publications will receive. And this is an example of publications that have come out after collaborations between different groups of academic institutions, the Alliance Group, the Russell Group, all other groups, etc., in a study that was published by the University of Portsmouth. So what you can see here is at the right-hand side, the right end, the green dots, how the number of citations, the field-weighted citation impact is increasing as the percentage of international collaborations is increasing. So to cut a long story short, the impact on the citation count is significant, and it has to do both with the extent of collaborations and the choice of collaborators. Both parameters one needs to weigh carefully when they set off to establish their collaboration network. There are, of course, challenges in research collaboration as well, and that can be a very long list. But if I was to list here again the top 6 challenges one can face, these would be challenges, for example, in decision making and accountability, which becomes considerably more complex the more different people you have, the bigger the number of scientists, of people that you have in your collaboration network. You can have differences in the individual or institutional goals that can create friction between scientists. You can have issues when it comes to sharing credit or even costs for the project and the findings. The project timelines can be harder to meet the more people are involved, because the more effort it takes to establish the momentum, the regular communication to keep everyone punctual and strict to meet their deadlines. Sometimes one will have to deal with conflicts from diverse participants, and this diversity can make it more challenging to reach a mutual agreement. Also, the cost of unsuccessful collaborations. If after all your efforts a collaboration does not go well, does not answer the scientific questions, does not yield the data desired, or if just the chemistry between the different collaborators is poor and the network falls apart over time, this can create a significant cost because of all the money and effort and time that will have been invested in this project up until the point where it falls apart. So of course, these are scenarios where things can go wrong. Their frequency varies, and for every single one of them, there are measures one can take, as we discussed, to avoid. Sometimes those things will go wrong, and this is where one will learn and ensure that in their next attempt, they will do things differently to achieve a better outcome. So in summary, the critical points for a successful collaboration: inspiring and motivating leadership, compatible collaborating partners, realistic expectations, mutual professional trust and respect, open, direct, and regular communication, and highly responsible attitude and diligence. If there is something to remember from this presentation, the most important slide would be this one here. These are absolutely critical, 6 critical steps for a successful collaboration. And these are characteristics, these are points that you should both seek to give but also seek to receive in your collaborations. So final thoughts. Successful collaborations promote individual scientist development, but also boost scientific progress and scientific outcomes. So it's both to your benefit, but also to the benefit of science to pursue collaborations, healthy, fruitful collaborations. It's important, though, to choose the right collaborators for the right project at the right time. So think carefully before you set out to build your collaborators network. And 3, invest time and effort to nurture your collaborations. It's not sufficient to just identify who you want to collaborate with, or to assign roles and then go back to your own lab and keep working. It takes a lot more to nurture a healthy collaboration over time. So do your best to keep it going, to extend your network, to refresh your network as your scientific needs change over time. And treasure every one of your collaborations and be careful to give, to respect, to share in an honorable and ultimately fruitful for all fashion. And with these thoughts, I would like to pass on the microphone to our next speaker, Arnie, who has some exciting information and tools to show you on how to maximize your collaborations, the outcome from your collaborations. Thank you.
Thank you so much, Despina, for this great in-depth presentation about collaboration. I think it would have been very helpful to me when I started my PhD to be much more considerate about engaging in collaborations and to get the most out of it. So what I will do in the next 9 minutes is share a few of my tips that I experienced as a PhD student in aging biology. I was active in multiple collaborations and I enjoyed the benefits as Despina listed. But I also had lots of ideas that I couldn't actually work on because I didn't have the right know-how. I didn't have the right I don't have the right know-how, I didn't have the right techniques, technologies, or instruments available to me. So I actually couldn't test lots of the hypotheses that I wanted to test. So they stayed somewhere in a drawer or somewhere at the back of my mind. And I guess that's the same for many, or actually every PhD student or postdoc, or even within companies. You can't do what you really want to do because you lack the time or you lack the certain know-how, etc., that you need. So the solution to that is actually collaboration. And I want to touch upon 3 topics here. One, finding ideal collaborators. And that can be relevant for if you start a new project to make it really successful, that project, to bring together the complementary expertise and assets. It can be when you need to do a specific experiment. During your project, you have some ideas, some hypotheses you want to test. So you can't do it yourself, so you need someone else to do it. Or it can be at the end when you publish and a reviewer says, hey, we're excited about getting this published, but it lacks one key hypothesis that you need to have an answer for. So you need to do certain experiments, but you lack the certain expertise or techniques to do so. And you need to do it in 3 months' time. So then it's ideal if you can find the right collaborator to do that experiment quickly so you can get published in that high impact journal. The second part is raising enough awareness so people can actually find you, so that you are asked to collaborate, to contribute to their own project. And so it's important to be visible, to ensure that people are aware of your capabilities, of your research group's capabilities. It's important that you can offer specific help so that you can share how can you contribute. Is it with a certain technique that you master? Is it with certain specific know-how? A certain instrument that is expensive and that you have at your disposal? And the third thing, it's important to build your own personal brand as well as for your research group. If you build this brand, you'll get a lot more requests for collaborations. And the third part is be proactive and engage with peers. By engaging with peers, you don't actually have to be scared to engage and to reach out to colleagues of you. I was scared in the beginning because I thought, okay, if I send an email, probably no one will respond. What will they think about me? But actually, scientists are curious. They love receiving emails stating that, hey, are you open for a collaboration? So don't be scared, just reach out to people, but be prepared. Do it decently, research who you are engaging with, and then be concise in what you send them. Another way to engage with peers is actually to bring your colleagues together. Research can often be lonely. You're often working on an island, so it could be very helpful if you bring together other PhD students working on your topic or postdocs, where you can easily exchange know-how, can exchange tips, can exchange learnings from conferences, etc. And a third point is use the right tools for the right job. So there are lots of tools available. Often it's very hard to know about them, but they can make your life so much easier. So I stopped my PhD to start with academic labs. And what we do is we want to facilitate in these 3 domains how to approach these things. So we build an all-in-one platform for research, matchmaking, and collaboration. And it has 3 different parts. One, it's a search engine to find ideal collaborators. And we focus mostly on research groups because they have the context that you need to identify the right collaborator. We also bring together the other information like publications, projects, patents, funding calls, etc. So to make it really easy to have all that information at your fingertips in one single place. The second part, we make it easy to make people aware about your capabilities as a research group, as an individual, or as an institution as a whole. And the third part, if you find a collaborator, you can actually use our tool to streamline the collaboration with another collaborator or with multiple partners in one private environment. And step by step, we're integrating these tools to further streamline the collaboration. Now, in the next slide, I will give you some specific tips and show you how you can realize that on academic labs. So for example, when you start with a new topic or you start with a PhD project, don't just jump into literature and start reading articles. That's a mistake I made and lost many months with that. First thing, zoom out and understand your niche domain. So how can you do that with academic labs? You can actually find or search for publications on your topic, and you can see in the filter, you can identify who are the top authors, who has published most on this topic. And if you then, for example, filter on only the reviews, you can start reading the latest reviews on your topic and have from these top experts and have a good understanding of what's happening in your specific field. Next thing, you can identify who are all the research groups active in my topic. So for example, I did it here for my own topic, and you can see there are more than 100 research groups. I can easily see which universities are more active on this topic. I can dive into details and find more information about each research group, etc. So this gives me a good overview of what is the activity, who is active on my specific topic. I can also understand what are the topics that these research groups are currently working on. So that helps me identifying what are the hot areas, which kind of topic do I see occurring regularly by many groups that are working on it, and what topics are actually not that actively worked on. So that could be an opportunity for myself to deep dive into that area. I can also find other projects, for example, European projects. I can find funding calls, the latest patents, services, clinical trials, etc. So we bring all that information together in one place so you can have an overview of the right information on your topic in one single place. And very interestingly, you can basically save your search, so you can combine your query, your keywords with the right filters and get alerts every time there's some new publications, new groups, new researchers, new projects, new funding calls on your topic of interest. So you always stay up to date on your field. Now that you have zoomed out and you understand your niche domain, it's time to identify who is an ideal collaborator. So how do you do that? You search for research groups in academic labs. So you do a specific search. And in my case here, you can find 28 groups working on my specific topic. So now I can actually look at every group and understand what they're currently focusing on, what were their recent publications, etc. In the past, without academic labs, when I had to do that, I had to find their websites, which was not an easy job. I had to scrutinize their websites to find out what they're working on, and it was often out of date. So we try to make it easier so that in a few seconds you have an overview of all the groups working on the topic and you can find the key information. A tip I usually give is first start with the local research groups. So for example, those in your own university, and get to know them in details. So for example, in my case, I look at Ghent University in Belgium. I can find 7 groups. I actually go to their profile and I scrutinize what they're working on, what they're focusing on. And let me give you an example on that. So this is a profile of a research group. I can see what's the mission for my query. I see the highlights. So I see what they're working on now. Where are they heading? The shared goals is very important if you want to find a collaborator. So this mission statement, the focus area that is critical to get this information. It also gives you immediately an insight on the research topics they are currently focusing on. And it gives you insight on the current project or the past projects, as well as the publications they have been published. And interestingly, you can actually deep dive into those publications. So if I'm working or interested in sequencing in this group, I can see they have 14 publications. I can actually understand what have they done on this topic recently, in which years were they most active in this topic, which top journals did they publish in? So is it a high quality group or did they only publish in lower ranked journals? Have they been more active in latest years? What are the co-authors they have been publishing with? Are these top experts? So this gives me a way to really evaluate a potential partner on, is this a right collaborator for me? And if you think it's the right collaborator, you can simply get in touch with them via our email form. So you can simply send an email to that person, to that group leader usually. And it's important that you be very specific in what you ask for. Be concise, be specific, and end your email with a very clear question. If it's too long of an email, the professor is too busy and he will never read it or he will not respond. So keep it short, keep it concise, and to the point. Now, there are other situations, not only when you start a new project. Often when you're doing a project, you need input from another discipline, or you need to tackle your hypothesis from a different angle, but you don't lack the expertise. It's out of your comfort zone. So you need some input from another discipline, or you need a specific experiment or analysis to be done, but you can't do it yourself, or you need a very expensive instrument, which you don't have, or to apply a new technique, which you have never done before. So if you do it yourself, you will lose lots of time. Maybe you need expertise in data analysis or statistics to help you in your analysis of your results. Or maybe a reviewer says, hey, do this specific experiment and then we can publish it. So don't try to do everything your own. You will be very slow. You will not succeed as much as you can do when you collaborate. So my advice here is to outsource that. Find the right collaborator, because for each of these things, there's always somewhere around the world who can help you on that specific thing and who would love to help you, because they also benefit from it. So how do we try to help with that on academic labs? Besides finding those research groups or researchers, you can actually find groups that offer specific experiments. So here on the slide, you can see someone who offers a certain CRISPR-Cas related service. So they can do this kind of experiment or analysis for you, so you don't have to do it yourself. So it's a way to also find other tools, find people who can offer these experiments, so you don't have to do it yourself. On the other hand, you can also offer that to others. So you can also leverage what you know, your unique tools that you have, your expensive equipment that you have, new insights that you gathered. So you can actually offer these as experiments, routine experiments, or more unique on-demand experiments. You can offer maybe consulting, advice, maybe new tools that you developed, data sets that you have, etc. So you can easily share that on our platform to make it visible to the world so they can find you and ask for your help. It's also important that you build up your brand, that you are visible as a research group and as a researcher yourself. So in academic labs, you have a profile for yourself as well as for your research group, which you can easily add information about the mission, the current topics, the research interest, etc. You can offer the services, and we automatically add new publications and eventually projects and other information. So we try to make it as effortless as possible for you. We actually already pre-populated more than 53,000 research groups of hundreds of leading universities. So you can already find that without them having to do any effort. So make sure you are visible to the world. We make sure you're visible on our platform as well as on Google and other search engines to get the most out of it. And a final point I'd like to make is about engaging with others. You can actually use our platform to bring together your peers. So you can create a kind of environment, a community environment. You can make it private or you can make it open, where you can easily invite your colleagues, your peers, and use this tool to find expertise amongst your peers, to share what you can offer to others. You can share what you are looking for. You can ask questions, for example, about certain techniques. You can create eventually a shared library with relevant publications that you share with each other, new projects, new patents, new funding calls, interesting conferences. So the idea is to make it really collaborative, to work together across borders to advance each of your career in a joint way. So academic labs is, we actually worked initially with lots of companies, from top pharmaceutical companies to smaller biotech firms, as well as with universities and academics. So today, Academic Labs is freely available for academics, so you can sign up with this link that you see on your screen. You can have free access to all the content. You can use it to find partners, to be visible, as well as to communicate and collaborate with your peers. And with our strategic partnership with Inaho, now you can also find their services easily on our platform and even get a 20% discount on these services. So if you want to get your publication in a high impact journal and increase your odds of getting there, I can only advise to use these services of Inaho.